So welcome back. Next up is Albert from Danalto, and he's going to tell you everything around the use cases they build with LoRa, and also what they do with LoRa 2.4 gigahertz. Enjoy his talk.
Hi, my name is Albert Baker. I'm a co-founder of Danalto, a Dublin-based IoT platform provider. We specialize in asset tracking and location services using LoRa at 2.4 gigahertz. LoRa 2.4 is a new low-power wide area networking technology operating in the Wi-Fi band. It comes with a host of performance characteristics which enable it to identify the location of sensors or tags without relying on any other tracking technologies such as GNSS, Bluetooth, or Wi-Fi. And today I'm going to talk about the top 3 challenges to do with asset tracking and how LoRa 2.4 helps to overcome some of the limitations of traditional location services solutions. So as we all know, connecting physical objects to the internet and enabling data exchange is a foundational capability of IoT. And it's essential for any organization that wants to gain insights into the efficiency of their business operation. Over the past several years, IoT has become more and more a part of modern operations, and it's now widely used across a variety of industries. But whether it's monitoring water levels in a flood-prone area or keeping an eye on the status of an employee in a high-risk work zone, a key enabler of many of these use cases is the ability to track the location and the utilization of physical assets and personnel, which are central to business operations. Despite the high demand for these capabilities, asset tracking still is faced with its challenges. And today I'll be discussing what we believe to be the industry's top 3 challenges and how LoRa 2.4 offers a new solution. So these are location accuracy and range, network infrastructure density, and power consumption. These 3 challenges combine to present a particular problem for anyone trying to track assets in wide open spaces. Wide open spaces could be indoor, like a warehouse, outdoor, like an open pit mine, or in outdoor spaces that are covered or obscured, like an oil and gas refinery, or in a deep urban setting. And tracking technologies have tended to be unsuited to open spaces due to their performance characteristics when it comes to accuracy and range, infrastructure density, and power consumption. So as a consequence, we see typically Bluetooth, ultra-wideband, and Wi-Fi being deployed in indoor environments, while GNSS being deployed in outdoor environments with a clear sky view and the ability close by to recharge device batteries. LoRa 2.4 is poised to underpin a new breed of tracking solutions, which will simplify tracking in open space, both indoor and outdoor. Now, let's look how 2.4 compares to traditional tracking technologies for each of these challenges. The first challenge is the ability to achieve highly accurate location data at short range and over a relatively wide area. These 2 elements go hand in hand, and their relationship can be a key determinant of whether the technology is suited primarily for indoor or outdoor use. This table here provides a breakdown of each of the technology's capabilities. So you will see that Wi-Fi, Bluetooth, ultra-wideband, and RFID, these are all by nature short-range technologies which render them best suited to indoor usage, while low-power wide area technologies like LoRa and Sigfox provide coverage over wide areas. Some of these offer location services native to the technology, but they cannot match the accuracy of the indoor technologies. For example, LoRa location services in the sub-gig band. This provides approximately 50-meter accuracy, whereas indoor tracking technologies typically offer in the range of 5 to 10 meters, all the way down to 10 centimeters. GNSS systems such as GPS provide the best of both worlds in that they are both accurate and long range. However, this only really operates effectively outdoors because they need to have a clear line of sight of multiple satellites. And these can be obscured by big trees, buildings, or coverings of any kind. 5G provides good accuracy but relies on a significant amount of infrastructure which is not yet available, and it also comes with the drawback of requiring operator subscriptions for SIM cards and cellular connections. LoRa 2.4 overcomes many of these limitations as it operates at a higher bandwidth uniformly worldwide. LoRa 2.4 is also not limited by time on air restrictions, which have hampered the performance of sub-gig LoRa for asset tracking and positioning. So crucially, this enables location accuracy from under 5 meters, ranging up to 5 kilometers. In summary, LoRa 2.4, it achieves GNSS-like accuracies independent of GNSS and in any wide open space, including an indoor one. Our next challenge is how much infrastructure is required. This refers to the amount of physical infrastructure required in order to provide asset tracking coverage for a given space. By this, I mean the number of routers or gateways set up in an area. Network density is really a function of operational range, and the longer the range provided by our wireless technology, the lower the density of physical infrastructure required. Referring to the table again, GNSS has the lowest requirement for additional network infrastructure. Tags enabled with GNSS capability work by comparing the time difference of arrival of signals which were sent from different satellites and triangulating them to determine location. However, GNSS does not support data connectivity, therefore requiring additional network infrastructure for data transit. So GPS systems can calculate location data, but how do we get it back to our platform? All other tracking technologies connect using localized anchor points, which typically broadcast on wireless networks. They use a variety of techniques, such as measuring signal strength, or SSI, in the case of Wi-Fi and Bluetooth, to calculate location. Each has its own performance characteristics, which also contribute to how densely packed the anchors need to be within a given space. For example, BLE or Wi-Fi require anchors every 30 to 50 meters, while LoRa at 2.4 can provide location services at similar accuracies over 3 to 5 kilometers. In the case of LoRa at 2.4, infrastructure density is second only to GNSS because of the higher frequency and wider bandwidth it leverages. This makes it a very interesting technology for outdoor tracking in scenarios where GNSS is not suitable, like a deep urban setting or where canyoning occurs. LoRa 2.4 operates in the same environments that GNSS can operate, but at a much lower power. So in the outdoor scenario, it also has an advantage here. Just finally on this point, vast amount of infrastructure on a deployment inevitably require maintenance over the lifetime of a solution. So if infrastructure can be reduced on a deployment, related supported costs are also reduced. Moving on to the last challenge, we have the issue of power consumption. So power requirements of the leading location technologies are worth careful consideration when designing your asset tracking solution. Ideally, tracking devices require zero or low maintenance. However, this only occurs if a tag's battery life lasts for a sufficient number of months or years or the lifetime of the solution that's being deployed. But in our experience of helping customers who rely on battery-powered tags, 30 to 40% of tags are lost or go offline at any point in time because of short battery lifetime. The replacement or recharging of such devices is time-consuming and expensive. The asset tracking industry understands the importance of helping their customers overcome these challenges around power and is evolving to enhance performances as a result, like low-power GNSS and these types of technologies that are coming out. But just to give an example, LoRa operating at 2.4 gigahertz can offer 5 times longer battery than traditional GNSS. Okay, so in summary, taking all of these challenges in combination, what is required for tracking in wide open spaces is a low power solution which offers high accuracy and long range combined with low infrastructure density. So at Danalto, we utilize LoRa at 2.4 gigahertz to achieve this for use cases like personnel tracking in open pit mining to improve health and safety measures, and also applied in heavy industry. Asset and personnel tracking for logistics indoors for optimization and for personnel optimization, and asset tracking in pharmaceuticals and manufacturing, reducing downtime and loss. We're committed to helping our customers overcome the challenges that I've just described, and these are all associated with campus-wide asset tracking. As part of this, we're incorporating support for leading-edge tracking technology that may complement LoRa 2.4, like ultra-wideband. Our platform features a distributed architecture which provides location intelligence firmware for tags and gateway manufacturers and cloud orchestration for implementers of asset tracking solutions. So later on during the conference, we will be demonstrating this technology with our partners, our gateway partner, who's Multitech, and our tag partner, who's Miro Miko. And we're going to show a use case. We're going to show all the way through the stack how this works and how we've proved out the accuracies and low power aspect that we've talked about. So check your agenda, and we really look forward to talking to you as the conference proceeds. Have a great day. Thank you.